Hi, so here we have a Dell PowerVault MD3000. So this is a storage array to rack inside a cabinet and connect to a storage server. So for now we have some hard drives plugged in and we have some controllers plugged in. So we have two controllers, both are iSCSI controllers. Depending on the configuration you got, you may have SAS controllers, so I also have a pair of SAS controllers I already fixed. And we have also two power supplies. So this system is fully redundant. The issue right now is that it doesn't initialize. So I'm gonna turn it on. It makes a lot of noise, so I hope I can filter it out, but we'll see. So I'm gonna turn it on. So right now it's still trying to initialize. So this is the orange light right here. What you just saw on the screen, and I'm gonna show you again, is the debug console. So right now I'm connected to the primary controller. So this is this cable right here. This is the serial debug console, and it is connected to the serial port of the laptop right here. So I'm looking at the debug output of the first controller, and as you can see, ignore the text above. It started turning on right here, and then it falls. So it doesn't continue. What we're gonna try is see what's happening with the second controller. So let's turn it off. Let's plug the serial cable to the second controller and turn it back on. And as you can see, it's doing the same thing. It's also frozen. So I'm gonna turn it off. Because it's very noisy. And the thing is that I already fixed the SAS controllers, and both of the SAS controllers had firmware corruption. So I'm pretty sure these controllers, which are iSCSI controllers, also have firmware corruption. So to fix the situation, you have to get into the firmware recovery mode. Unfortunately, since the firmware is present and is trying to boot, we can't get into the firmware recovery mode. You need to have a blank NAND chip so that it detects that there is no firmware on the controller and initialize the firmware recovery mode. There are two methods to get into this firmware recovery mode. First one is replacing the chip with a new one or blank one. Second one is using a programmer to erase the chip. So I can do both, but just for the sake of the video and since it's the faster way, I'm just gonna replace the chip with a new one. Then we are gonna see how to restore the firmware with the update package from the Dell website. So we are gonna remove both controllers. So first disconnect it from the latch. There is the second one, and there is the first one. So we have two controllers right here. So we have one controller here. So I already removed the screw. So you have two screws here, two screws, three screws here, and two here. And then you open it up from the back right there, and you lift up the cover. Perfect. So inside this module we have a few things. So here is the battery for the backup for the write back cache. So we are gonna remove it. So we are gonna remove this battery. Okay. You have a screw and you can pull it out. Good. We have a RAM stick for the firmware and the cache. So we are gonna leave it there. We have a board. This board is for the iSCSI extension. So the controller with the SAS extension got another board right there, but we don't care about it right now. What we're interested in is this chip right here. So this contains the main firmware for the board. I already removed it and read it from the programmer to see if I could do anything, but it's corrupt. So that's why you see some flux around here. What we're gonna do is remove it again and replace it with some replacement chip right there. So these chips are some parallel NANDs. So these ones are, let's see, HY27USO8561A from Hynix, and they will work perfectly fine over there. So let me try to use the hot air station. So we have our hot air station right here. Okay, so 390 degrees Celsius and 105 air should be fine. Let's grab some tweezers. Okay, and now we're gonna remove the chip. Let me just put some shielding on the FPGA just next door. You never know. Okay, so let's use a shield. Okay, perfect. And let's go. Here we go. So let's put that to the side. Okay. We're gonna clean the pads from where the chip was. Okay. Let's do this. Let me put some more flex on it. Okay, let's try that again. Okay, we're good. So we're just gonna clean a little bit. Okay, good enough. And now we are gonna use some of our new chip. Okay, so on this chip we got pin 1 over there. So on the other side it's here, so it goes this way. We have the dot over there to indicate pin 1 and the notch over here to indicate the side that has pin 1 as well. Okay, so let's roughly put the chip in place. We're gonna put some flux here and there, because what we are gonna do is just tack one side of the chip. Let me use the knife blade for the soldering iron. Yeah, gonna be better like this, okay, with a little more zoom. So yeah, as I said, you can see the pin 1 over here, and pin 1 under the chip was indicated over here. Okay, so we are good. So we are gonna add some solder on our chip. Okay. And we're gonna try to align the chip. Maybe by hand. Okay, so we solder some of these pins on this side and some of the pins on the other side as well. And make sure we are properly aligned. Should be good. So now we are gonna add some more flux. And add some more solder and solder the pins. So first we make sure we got solders on all the pins and pads, and after that we're gonna take care of bridges and excess solder. So we have a blob on one side, but it's not our main concern for now. We're gonna do the other side. Okay, so all of our pins are soldered properly. So we add some more flux. And now we take care of the bridges. Okay, so we should be good on this side. Let's do the other side. And we should be good too. Let's just get a closer look at it with some light. Maybe on the camera it doesn't look really good. Okay, so now I'm gonna go ahead and clean that a little bit. Okay, good. So we can put back this card. Okay. I'm gonna put back the battery. Put back the cover. So we don't have any screw to hold it together, but doesn't matter. So for now, I'm gonna just do one controller. So in fact, for now, I'm gonna put back in the second one that still have current firmware, because you have to flash them one by one. So let's do the first one now. Okay, so to flash the firmware, so this is from the Dell trading tool for the MD3000i. So this is the iSCSI version, but it also applies to the non-SCSI version, so the SAS version. This is supposed to be confidential material, or at least not publicly available, but thankfully someone posted it on the internet very recently, just last year. So the procedure to flash the firmware. So we have a procedure for Windows, so you can do it on Windows. We also have a procedure for Linux, which is what we have right here. So on Linux, we have the Minicom serial terminal, which is what we are using to see the debug log. You can see the configuration for the serial port right here. Just a very important parameter here is the hardware flow controller. It may or it will probably not work. If hardware flow control doesn't work, you are not able to send any command to the controller. So we have to disable the hardware flow control. So this is what we are gonna do. And we also have to set terminal emulation to NC. So for now, we are in the firmware download mode. We have to press 3 spaces. Then we are gonna see a prompt to tell us to send the file through the XMODEM protocol. So the XMODEM protocol is a protocol to send binary data through the serial port, which is supported by XMODEM. So XMODEM also requires the package LRZSZ package to be able to use the XMODEM protocol. Otherwise, you are gonna see no errors, but it's not gonna start the transfer. The firmware package itself can be downloaded from the Dell website. So we're gonna look for Dell SCSI and the firmware version because we want the SCSI variant, not the SAS variant. So this is what we got here. Let's accept this, we don't care. So we download the zip file. Okay. So this is our zip file. So we are gonna extract it. You can see the top of the window. So we are gonna unzip it into /tmp. Doesn't matter, but that's what we are gonna do. Okay. So we unzipped a few files. So if we look here, it's this file. So we have some NVS from file. So for now, we are not gonna care about it. We are gonna flash the MD3000i file, which is this one. So what we're gonna do now is launch Minicom on the hardware serial port right over here, so /div/ttys0, which is the hardware serial port on this Dell Latitude D520. I tried with some USB dongles, it didn't work, so that's why I'm using a laptop with a hardware serial port, which is working fine. So let's now launch Minicom. We're gonna check the serial port setup, so we want to press Ctrl A, then O, Ctrl A, then O, and go into serial port setup. Into the serial port setup menu, you want to check that you are into 115,208 baud rate bits parity and start-stop bits. And you want to check that hardware flow control is disabled. In this case, hardware flow control doesn't work, so if you try to send any command to the controller through the serial port with hardware flow control enabled, it's not gonna work. So that's good. And now we're gonna check the terminal emulation, so press Ctrl A then T, and then press A to change to NC terminal emulation. Okay, so now we are good. We can turn on the enclosure. It's gonna make some noise, so bear with it. Okay, so right now we can see that the controller is turned on in bootloader mode since the system firmware is missing, as it tells us. It tells us to press free space, so we are gonna do this. And then it's telling us that system firmware is missing. We already know that. But it tells us to download using the serial XMODEM protocol now. So to use the serial XMODEM protocol, we are gonna press Ctrl A, then S, select XMODEM. We are gonna go to the /tmp folder where we extracted the firmware. So our firmware is this file, MD3000i something. So let's copy the file name. Let's press OK and enter the file name. Let's enter. Okay, so the transfer completed. So now we can press a key right here, and we are seeing that the firmware is being flashed to the NAND. So we have several partitions getting flashed over here from the file we transferred, and right now the controller rebooted. It's doing its power on self test. Every test passed, so we should see the controller booting. Right now, if we take a look at the hard drive, they are loading up. Controller is booting, so the fan speed is going down. So if we take a look at the log, so we have stuff going on. We are gonna wait for a little while. It takes a few minutes for the controller to fully boot. So we just have to wait for now. Okay, so it's getting further down the sequence. So right now we can see the debug message about the version and the type of controller. And basically when we get the SOD main complete message, the power sequence has completed. There are a few things going on after that, but it doesn't matter. So right now we can confirm that this controller has a good firmware that allows it to boot fully